So now I'd like to talk about two important concepts that are unique to clinical trials: randomization and blinding. So randomization is the allocation of subjects to treatment groups by some chance mechanism. Now, oftentimes you will read or see a study where the randomization was performed in a 1-to-1 ratio. All that means is that there was an equal number of subjects enrolled in one group compared to the other group. However, for efficiency purposes and sometimes for concerns of safety, randomization ratios may be in a non-1-to-1 ratio. For example, we could have a 2-to-1 randomization ratio where for every 2 subjects enrolled to the treatment arm, 1 subject is enrolled to the control arm. That approach may be chosen if there's a desire to reduce or limit the number of subjects who are enrolled in the control arm. You can also have the reverse, where you have a 1-to-2 assignment, where you have 1 patient in the treatment arm to every 2 in the control arm. That's oftentimes less the case, though. And for randomization, the unit of randomization can be either the subject, which is going to be the case in a clinical trial, or the group level, which would be the case in a cluster randomized clinical trial. Now, when randomizing individuals to treatments, it is best to have some separate study number or separate randomization for each individual. And oftentimes in clinical trials that involve multiple research centers or sites, individuals are randomized to small groups of numbers or letters. For example, they may have letters A through F in that trial, where half of the letters represent the experiment and half represent the control. There are various approaches to this, and the whole goal is to essentially reduce the likelihood that the researcher would be able to predict the next treatment assignment for the patient that they're currently enrolling. Now, what randomization does is it prevents the biased allocation of exposure or treatment to subjects that we know can occur with other methods. It also tends to balance the treatment groups or treatment arms with respect to known and unknown baseline factors. This is an important characteristic of randomization that is unable to be achieved with any other type of study design. While we have many analytical approaches to control for imbalances in baseline measured factors in, say, a cohort study, we are always unable to control for the unknown factors because they simply weren't collected. So assuming a sufficient sample size, randomization will almost always ensure balance of the factors that were both collected as well as not collected. Also, randomization provides a clear baseline or timestamp for the longitudinal assessment of study subjects. That isn't always clearly defined in a cohort study, and it's really difficult to determine in a case control study. Randomization also provides the basis for parametric statistical testing, and essentially what this does is it allows for the use of our standard statistical testing because those rely upon some assumptions of random samples. And then along those lines, randomization also creates a representative sample. Now, randomization isn't always successful at everything. For example, randomization does not ensure a random sample is drawn from the population into the clinical trials. And what I mean by that is randomization cannot protect against the bias that may occur in who chooses to participate in a trial and who chooses not to. Similarly, randomization does not protect us against which researchers or clinical centers choose to participate in a clinical trial compared to others. And then thirdly, if the trial is not performed well or wasn't designed appropriately, randomization will not ensure that our statistical testing approaches are appropriately performed. The next topic I want to discuss is blinding or masking, and I'm going to walk you through the different types of blinding or masking. Now, you may have come across a study in the past that said that the treatment assignment was given in an open label design, and what that meant is that all parties involved in the clinical trial, the subjects, the researchers, the pharmacists, the nurses, etc., all knew the treatment assignment for all the patients involved. In contrast, the alternative approach is to blind treatment assignment. And there are different approaches, but basically blinding is blocking the identity of the treatment assignment from one or all parties involved in the study. So the first kind is single blind, and this is simply when either the subject participating in the trial or the investigator performing the assessment on the patient is blinded to the treatment assignment for that subject. And the choice between the patient or the investigator being blinded really is driven by what the overall goal is in attempt to reduce the bias. The second kind of blinding is a double-blind approach, and this is when neither the subject nor the researcher knows the treatment assignment for their subjects involved in the trial. And there are examples where findings from double-blind clinical trials have differed from those from single-blind trials, and really boils down to the assumption that there is still some sort of treatment assignment bias in the single-blind clinical trials. Now, as you would imagine, these are more logistically complicated, and the reason for that is because in a blinded trial, double-blinded trial, or any trial that's blinded for that matter, there needs to be masking of the products that are given. So they need to look the same, taste the same, smell the same, etc., so that no one in the trial can figure out what the treatment is. And then the third design is called a triple blind. This is a much more rigorous approach, and this basically is a design where no one knows the treatment assignment. And so no one, including, say, the pharmacist who's responsible for dosing or dispensing the medication, the clinical researcher is blinded, as well as the patient is blinded.